Then let me discuss reciprocating engines. After I briefly introduce reciprocating engines, then we are going to move to the spark ignition engine. So the reciprocating engines are engines that have piston cylinder assemblies in it. Okay, as I discussed earlier. So in that type of engines, piston should go up and down, and these up and down motion, reciprocating motions, are converted to shaft motion, rotating motions in the crankshaft. There are two types of engines in the reciprocating engines. The first one is spark ignition engine, or SI engine, and the other one is compression ignition engine, or CI engine. So those names are classified based on how combustion are ignited. The spark ignition engine have a spark plug that ignites combustion process. The CI engine, or compression ignition engines do not have spark plugs. Instead, it compresses the air and fuel mixture so high such that this ignition starts by itself after compression process. So that is why we call that as compression ignition engine. Okay. The SI engine uses gasoline because gasoline is really volatile, such that we can use that as a kind of a good fuel for spark ignition engine. So the different name of SI engine is gasoline engine, and this gasoline engine is typical engines that we use for daily cars or like automobiles that you drive. The compression ignition engine usually use diesel as its fuel. So many times we call it as diesel engine. So both engines are operating based on different cycles. The SI engine is based on the Otto cycle, which we are going to talk a lot about maybe today and in next lecture. We also are going to talk about the diesel cycle later. So in fact, diesel and Otto are people's name who invented that type of cycle. All right. So let me move on to spark ignition engine, or SI engine. Okay. Now, I really want you to pause this video and try to find out, please, find out the video file that I uploaded to Canvas separately. The reason that I uploaded this video file separately is to protect the copyright of this video. So please pause this video and look at the video file that I have uploaded to Canvas. So that shows engine assembly of a SI engine, where you can see a lot of components that is in the gasoline engine. Okay. So it might be fun for you to guess what kind of components are there. I made those parts from the top to the bottom that should be shown in that video clip. So please, make a guess, about, where those parts are assembled in your engine. Okay. But basically, this engine has 4 cylinders, as you see here. Okay. So please enjoy your video file. But what I'm going to use is I'm going to use this simple schematic diagram of 4-stroke spark ignition engine with a lot of parts. Okay, so those parts, please try to make a match with those schematics. Okay, and what you watch in your video. Even though it looks simpler, but basically that video file image should have all those kind of core components that we see in this slide. Okay. Now let me just briefly explain what they are. So those are intake and exhaust pipes or manifold. And as you see, those are valves. Okay, we have intake valves and we have exhaust valves. Okay, and these valves are connected through a camshaft. Okay, and this camshaft is it moves by this old cam movement. Okay. Now also you can see this one, that is spark plugs. So because we see now those spark plugs, this engine is spark ignition engine. Okay. Now this spark plug is located in a very small chamber above piston. So now you see piston here. Okay. So that is your piston. Okay. Then that is connected, this piston connected to the crankshaft, which is a main shaft, by connecting rods. Okay. And this piston goes up and down, and by means of this connecting rod, and this up and down motion is converted to rotating motion. Okay. So that is your main part. Now I'm not going to discuss more details of this engine, but we are going to focus on these key features of the SI engine, which is piston and combustion chamber, or overall in cylinder, okay, and valves. So then there are a couple of terminology that we have to use. We basically use in general to describe the engine operation or engine engine motions. Okay. As I said, we should have intake valve through which we have air or air fuel mixture intaken to your cylinder of your engine. Okay. Then there is another valve that is called exhaust valve. And when this exhaust valve opens, then all burn gas after expansion process should be exhausted. Okay. Now, piston moves up and down, and there must be certain, the highest point where the piston can go up. And we call that position as TDC, or top dead center. There's another position that piston can go down to. Okay, the lowest position where the piston can go down to is called BDC, or the short name of bottom dead center. So now piston should move up and down, from BDC to TDC. And that displacement of piston movement is called as stroke. Okay. So while piston goes up and down, there must be certain, the compression process or expansion process. But even after your piston, even at the maximum, the highest point that piston can go up to, there must be certain kind of space to protect the valves and to have certain space for combustion. And now spark ignition, spark plug is usually here. And this spark plug also needs certain space. So that type of space at the highest position of piston at TDC is called clearance volume. And that is a minimum volume that air can be taken, after at the position where piston goes to the maximum highest point, and we call that as BC. Okay. Then, when the piston goes down to the bottom dead center, and we call that as, not really, we call it as VBDC. So maximum volume, then this air can take during this entire operation of the engine is per cylinder is BDC volume. Okay. So now what is important volume for the thermodynamic analysis is the displacement volume. We call it as VD. Okay. So now VD is VBDC, the maximum volume, minus VC, which is the clearance volume. And that is volume, the displacement volume is the volume that is swept by the piston during the piston movement. Okay. Now, with all these descriptions of required symbols and names, now we can define one very important operational parameter, that is compression ratio. Okay, so again, remember that this compression ratio is the most important designing parameters for the spark ignition engine, or the Otto cycle that we are going to talk a lot in next lecture. And now, how can we define the compression ratio? So the compression ratio, and we use R as a symbol, that is defined as the V maximum divided by V minimum, okay, of the air that takes your cylinder. And now, in that case, your V maximum of that type of cylinder piston assembly is V of BDC. And V maximum is VTDC. And you know that this is the clearance volume, and the maximum volume is displacement volume and summation to the clearance volume. Okay. So again, please remember that this compression ratio compares the maximum volume that is taken by the air inside the piston cylinder assembly in a spark ignition engine, or in general reciprocating engine, to the minimum volume, that is the clearance volume. Okay, we are going to revisit this definition later, after when we discuss the ideal Otto cycle in next lecture. But now, please remember that the definition of this compression ratio. Again, as I said, this compression ratio is the most important designing parameters, and for spark ignition engine, in general, the compression ratio is in the range of 8 to 11. And compression ignition engine has a compression ratio from around 12 to 24. We are going to discuss why the spark ignition engine is limited in terms of compression ratio up to 11, and why compression ignition engine has a lot higher compression ratio later. But please, keep those numbers in mind, as a kind of general design parameters of compression ratio for those kind of different types of engine.